All right, so this is gonna be number 7 from your review on page 192. And essentially what this is gonna ask us to do is create an equation that meets those 3 separate conditions. And so what I'm gonna do is just basically build them one piece at a time kind of thing, right? Where I'm trying to put the components in place. The hardest one maybe is gonna be the last component, okay? So it's a rational expression. And I know it's a rational expression because we're in the rational expression unit, but also we have vertical asymptotes, which means there's going to be some restrictions in the denominator, right? And so we have vertical asymptotes at -4 and at +5, right? So if I was sketching the graph, I would have vertical asymptotes in here at 5, at x equals 5, and then I'd have one at -4 as well, right? Okay, and so we also have, in addition to that, we would have a horizontal asymptote here. Okay, so this is like the bare bones of our rational graph. Okay, and the last condition wants us to, for the intervals that are less than -4, so basically everything over here, the y values have to be negative. So they have to be down in here somewhere. Okay, and y is less than 0. And then it says over here for x greater than 5, it also has to be less than 0. Okay, so what I'm gonna do is just build maybe the pieces. So I know in order to get, for this, the degree of numerator must be greater than, less than the denominator. Okay, so that just means we're gonna have 1 over something, or x over x squared, or x squared over x cubed, that kind of thing. And so I'm just gonna start with something like 1 over a bunch of x's, or 1x or 2x, okay? And then it tells us the vertical asymptotes, and back to the beginning of this, we said the restrictions. I know this is a rational expression because of the presence of the vertical asymptotes, and that they are occurring at -4 and +5, okay? And so I'm gonna write x plus 4 times x minus 5 in the denominator. This is gonna be my function, okay? So that would pretty much produce all of the pieces that I've drawn there, with one exception. And the one exception is, how do I satisfy this third condition? And so what I need to do here is to take that into consideration. And I'm gonna do that by, if you guys were actually graphing this, you would say, to figure out where the graph is, you would check, let's say f at -5, for instance. Like if I wanted to know where the graph was down in here, I'd put in an x value of -5, right? And then I could see if my value came out to be positive or negative. So what I'm gonna do is just evaluate this function at -5 and see what happens, okay? So if I evaluate the function at -5, I'm gonna get 1 over -5 plus 4, and -5 minus 5. So that's going to end up coming out to be 1 over, let's say, -1 times -10. So that's positive 1/10. So that actually does not satisfy that third condition, right? So we're close. But what I'm going to do to finalize this question is I need that thing, whatever that is, I need the y values at -5 for x to come out to be negative as per the third condition. So all I'm going to do, and this is going to finish the problem off, is I'm just going to say f of x is going to equal to the vertically reflected version of that graph. So I'm just going to make the whole thing negative. And now if I were to evaluate this thing, I'd have that extra negative out front, right? Which would make the 1/10 negative, and it would satisfy the conditions on the left, but then also for any conditions on the right, like let's say I evaluated the function at f at 6. Now I'm going to get -1 over 6 plus 4 times 6 minus 5. So that's going to be negative 1 over 10 times 1. So I would also get the negative 1/10 here, and we'd be good. Satisfies that condition. So for x greater than 5, y has to be less than 0. So at f at 6, y is coming out to be negative. So we've satisfied all 3 of those conditions with this equation that I developed. Okay, so that's it for that question.